All right, hope everybody's doing all right. This is going to be 7.5. First thing you're going to need to do here, if it hasn't already been done, is you're going to need to change the 7.3 to reflect that this is 7.5. So 7.5. You're going to do these 3 questions and then I'll come back and we'll talk about them. So pause the video and work out the 3 problems. See you in a couple of seconds. All right, so these would be the answers. The dot product was 0. The range would be everything from 7 to 11 because you're shifted up by 9 and you have an amplitude of 2. And then how many triangles? There would be 0 triangles because if you set this thing up and then try to find the height is going to be 9 times sine 57 degrees, which is 7 point something. And because that's the case, there are no triangles because the height is larger. That means that the B side will never touch the BC line. It will just swing. So 0 triangles. All right. Our goal today, we're going to find the solutions of systems of inequalities through graphing. A system of inequalities is a set of one or more inequalities of the same variable. Steps for graphing an inequality. Replace the inequality with an equal sign. Oops, and then it does that. So replace it with an equal sign so that you just have regular equations, and then you're going to solve those equations however you need to be able to graph. Here you're going to have solid lines if you have a greater than or equal or a less than or equal, and you're going to have dash lines if you have a greater than or equal, greater than or less than, but no equal sign. Then you want to pick a test point and substitute it into the inequality, but don't pick a point that's on the line or the curve. If you do that, then you're not going to really get a fair answer for that. So just pick one that's in an open space. If the point yields a true statement, then you would fill that part in. So how does this work? Well, let's take a look at what we're talking about for this particular thing, looking at this first graph. Now, first of all, you got to recognize what you actually have here. This would be a line. This one up here, this one is a circle. You've done those in geometry. It has a circle with a radius of 3. So that's basically what we're looking at. We want to graph both of those things and then put them in the picture and shade what we need to. So the first thing, being that the graph doesn't have it, we have to have an XY coordinate plane. So we're just going to create our XY coordinate plane. And now I'm going to go up here and just do what it said. For the circle, it's not shifted because x squared plus y squared, that means this thing has not been shifted in any way off the origin. So for the circle, we can do that one fairly quickly. The center of our circle is right here at the origin, and it has a radius of 3. So we're going to go down 3, over to the right 3, and then as best you can, try to make your circle. I know it's not the easiest thing to do, but do your best. So there's our circle. Now, for our circle, it says less than. So if we think about less than, that should be somewhere inside the circle. It's inside the radius because the radius is the largest part. So if I just pick 0, 0 and plug it in, 0 squared plus 0 squared is less than 9. That is true. So I would be shading the inside of the circle. Now, I'm not going to do that right now because otherwise you get a lot of shading going on. I'm just going to shade the result, but I know that I'm inside this circle. Now for this one, I want to solve this one, but I'm going to leave this. It said to change this to an equal sign, but I think I'm going to leave it because I think it's important with lines especially that you understand how this works. First thing we would do is subtract 2x. And then you have to divide by -3. But when you divide by a negative in an inequality, this thing changes directions. That makes this 2/3 x and then minus 2/3. Now, we could graph it that way. We only really need 2 points. That's the key here. So you only need 2 points. I'm going to put it in y equals mx plus b form so we see it, but you could do it as well right here by using the axes, the y-intercept and the x-intercept. So if I want to find the x-intercept, well then the y value is going to be 0, no matter what, no matter where you are. So if I just use that, then it's 2x is equal to 2, so x would equal 1. So that means it's going to cross right here. Whoops, let me get a different color. So it's going to cross right here. And then if I do the same over here on this side, I put in 0 for x, that means negative 3y is equal to 2, and this would be y is equal to negative 2/3. Well, it's kind of the same idea. Here's your b. And so since your b is negative 2/3, it's going to be right about here. And you would have 2 points. Pick something with a straight edge and draw your line. It's kind of important that you do that here. I'm going to see if I can do that with the papers that I have, but I haven't been very successful with this, which means I would need a few more points. But maybe I'll get lucky with this one. All right, something like that. This one, whoops, and then I do that when I shouldn't have. One thing to keep in mind, this was a less than situation, which means it's a dashed line. So just use something with a straight edge. Do your best to line it up, and so there is that particular line. Now they want me to shade the regions that are this one. But if I just look at this line, this over here, the reason I like this, it said less than. Less than means below the line. Okay, and that would be something that I would want to think about. I'm trying to pick a spot that's going to be in this region right here. So I'm going to pick this point, and I'm going to test it. That point is 1, negative 1. And I'm just going to plug it into both equations and see if it's true. So if I put in the ones here, it's going to be 1 squared plus 1 squared. That's going to be 2. 2 is less than 9. That works. If I put it in the other one, 2 times 1 is 2. And 3 times negative 1, negative 3 times negative 1 is positive 3. So 2 plus 3 is 5. 5 is greater than 2. That one checks out, which means the area that I'm going to shade is going to be right here. All my solutions should be found in this area somewhere. So hopefully that makes sense. You're just shading the region where you find all your answers. All right, that was for a circle and a line. So let's look at this next one. This next one is saying the following, that it is a line. The first one's definitely a line. The second one, this is a y squared. Well, if x were squared and y wasn't, this would be a parabola pointing up or down. When y is squared and x isn't, it's going to be a sideways parabola. It's really just a square root function. So this is going to be a square root function. And then this one is also a line. And so now I just need to put things into my my picture so that I can see what exactly is going to happen with this one and go from there. So first things first, I'm going to graph the simplest one, which is the x equal or greater than negative 1. So let me do that real quick. Hold on a second. Keep messing this up. All right. I do need an xy coordinate plane, so let me put that in first. I'll just say here's my x, and here's our y. Oops. Man, butchering this. All right. I'll go to that first one. It is a negative 1. So and it is a dashed line. So here's the negative 1. That one was easy. And for this one, it's saying greater than negative 1. So I'm going to be shading to the right of that one. I already know that. So right, I'll just say. Then I've got a line here, so I got to graph that one. And the line I'm going to have to solve. So this is going to say less than or equal to, this is negative 3x plus 3. So I'm going to go up to 3, 1, 2, 3. It's got a negative 3, so 1, 2, 3, and over 1. Hit me here. This is down 3, down 3, down 3. So here's our graph for this line. It is a solid line doing something like this. Mine won't be as straight. Kind of hard to do that. Now, the last one is the square root. So to solve the square root, I first need to change it by solving for y. So I'm going to add 4 to this side, so plus 4, and it's going to say less than or equal to y squared. And then I'm going to square root it, and I'm going to flip it around. So the open part of that is headed toward the y. Make sure you keep that in the same reference. Taking a square root, which is a plus or minus, and I have an x plus 4. So to graph a square root, we first got to think about what can't we have inside? Well, we can't have negatives inside. So the only thing we can have is 0, because we can find the square root of 0, or bigger numbers. So that means then I got to figure out what makes this 0. Well, negative 4 makes that 0. So it tells me at negative 4, 0. 1, 2, 3, 4. There would be my first answer. And now I'm going to try to find other values that I can find the square root of. Well, that means something bigger than negative 4. That would make a 1 right here, and square root of 1, that would be 1. But this one would be a plus and a minus 1. So when I go to negative 3, I'd go up 1 and down 1. If I put in a negative 2, I get a square root of negative 2. I don't like that. If I put in negative 1, I'm going to get a square root of 3, and I don't like that. But 0, if I put in 0, I'm going to get a plus or minus 2. So I'm going to go to 0 and plus or minus 2. That would be right here and right here. And then I'll try to find one more just to finish out my picture so I know where I'm heading. That means plus or minus 2. The next perfect square that I want to try to find, that's kind of what you're looking at, would be if I could get this to turn into a 9. And if I could get it to turn into a 9, well, that makes 5. So plus or minus 3. So I'm going to go over 1, 2, 3, 4, 5, up 1, 2, 3, down 1, 2, 3. Here is my sideways parabola. Whoops. So now I've graphed all 3 of those. Now I got to figure out where am I going to shade. Well, for the sideways thing, it said greater than the parabola. Greater than the parabola, that usually means on the outside. So if you're not sure, pick a point. I'm just going to pick 0, 3. 0, 3 looks like one I could pick that's outside. So if I say 0, 3 here, then 0 is here, 3 is here. Sorry, that's the wrong one. 0 here, 3 here. That's going to be 0 on the left side. 3 squared is 9. 9 minus 4 is 5. 0 is less than 5. That works for that one. So it's outside the parabola. It was to the right of the blue line. And now the red line. I got to figure that one out. It says less than that line, which would indicate that it should be below the line. I'm going to use 0, 0 in this one. So 0 here and 0 here means 0 is less than or equal to 3. That is true. So because that's the case, I'm shading in the parts that I would need to shade in. At this point, what are those parts? Well, here's one of them, because you have to be outside the parabola, left of the red line, right of the blue line. And outside the parabola, right of this line, below the red line. So all of this area would also be part of your answer. And if you're not sure, pick a point, test it, see what you come up with. Let's take a look at this next one. Now, this one's a rational function, and this one, to graph this one, we'd start with the same idea that we're going to have for this other one. So I just want to, I'm going to do this. I'm going to put this right here. So this is my x, and this is my y. Oops, wait, I don't want to do that one. I want to go lower than that. I'm actually going to go down just a little bit lower. So I'm going to go down here. Now, what is it we have that we're graphing? Well, the first one is a rational. We need to know how to graph a rational. And then the second one is a parabola. So we're going to graph the second one. I'm just going to do that one first. It's pretty easy to do. Because there's no other thing, this is vertex form. So at 0, 1, we're going to have our vertex. And it's got a stretch of 4. So right 1 up 1, 2, 3, 4. Right 2, we'd go up 16. We're going to be way up there. So this thing's just going to do something like this. And this one's saying greater than. Greater than actually means inside of that thing. So we're going to be inside the parabola, inside the U. Now I'm going to look at the rational, and I'm going to graph that. This one is in HK form for a rational. So my horizontal asymptote is at 2 because it's what makes the bottom 0, 2. So I'm just going to put in my dashed line here. And then my horizontal, sorry, that was my vertical. My horizontal is going to be right here. And then I'm going to graph this. So I'm going to graph it by just choosing a point to either side of the vertical asymptote. I'm just going to use 1. When you put in 1 right here, 1 minus 2, negative 1. That's negative 3 plus 3, that's 0. So the point 1, 0 should be in this picture, meaning right here. And since this is the new center, from the new center, I go left 1 down 1, 2, 3. That means right 1 up 1, 2, 3. Here's this point. And now, because there's symmetry involved in this, I'm just going to use the idea of symmetry. If I went right 1 from the new center, right 1 and up 1, 2, 3 to get to that point, then I'm going to go left 1, 2, 3 and up 1. That will give me the other point I need. And I'm going to do 1, 2, 3 and down 1 right here. So this thing is going to run along here like this. This one is going to run along here like, let me do that again. I don't want to make that one too bad, and then I mess that up. This one, let me fill this back in. It's going to come around that corner, and I'm trying to make sure it's kind of wide enough here so that we can see it's going to do something like this and then down this way. And now, this one says less than. So if I'm doing less than, what does that mean? Well, less than means it has to be under the curve. But here I have two curves. So less than really would imply, hopefully, that I'm under the lower curve. That's where all my solutions should be found. But I'm just going to look and see if that's the case. I'm going to pick a point that's outside of this, maybe this one right here, just to test it, over 1, 2, 3, and up 2. So I'm using 3, 2 to test whether I'm less than this curve. If I plug in 3 into here, that gives me a 1, that's going to be 6. So this side is going to say 6. This side says 2. That is true. I'm less than that curve. Okay. That means anything probably less than that. 0, 0, if I choose 0, 0, because that's this point right here, and it is under the second curve. If I plug in a 0 right here, that's going to be 3 over negative 2, which is negative 1.5, plus that. That's going to give me 1.5. And this being 0, well, 0 is less than 1.5. That's true. I'm less than that curve. Just to verify, if I go over 1, 2, 3, 4, and up 1, 2, 3, 4, 5, 6. So I'm going to choose that point right there. So 1, 2, 3, 4, 6. If I plug those values into this thing, 4 into here makes this a 2 at the bottom. 3 over 2, that's 1.5. That's going to be 4.5 on this side. And 6 is on the other side. Well, that is not true. So that tells me I'm in the right place. I have to be below the curves, which means the place where these two things intersect is just right here. This is where the only answers are going to be found. Now, keep in mind, your parabola will go all the way up, and it will eventually cross this green line. It will keep moving outward. But since we can't be above the green curve at the top up here, these two, the area that would be up here would not be an area we need to shade. So it's just that area there. Hopefully that makes sense. If you don't remember how to graph rationals, you definitely need to go look that part up because that's going to be something you need to know. Let's look at this next one. So we've got two curves, same with everything else. You start by doing this, and I don't know for this one, not sure what I want to do here. Let's see. I can just do a normal thing here, so I'm just going to start right here. So here is this particular one. Now I'm going to graph both of these things, and I'm going to see what we have. First of all, what do we have? Well, this looks more like a circle again, but now it's shifted. We'll talk about how that works. And this is an exponential. So we'll talk about that one as well. We're going to do the circle first. The circle right here, this is your H, this is your K, and they are opposite of what you see. So the center of this thing should be at 2, 1. So I'm going to go over 2 and up 1. Here's the center. And then it has a radius of 6, well, it has a radius squared of 16, which means the radius, being that this would be an r squared, is going to be 4. So I'd go up 1, 2, 3, 4. I go left 1, 2, 3, 4. Go down 1, 2, 3, 4. And go to the right 1, 2, 3, 4. And this thing, just like the last one, do your best. I know these aren't the easiest things to draw sometimes, but do what you can. All right, there's my circle. Now it's saying that it is less than this. That means it's inside the circle, just like it was in the last problem. Now I'm going to go to the next one, the exponential. Easiest way, just get yourself a table, especially if it's simple like this. If you were to plug in, let's say -1, you'd get a half. And if you put in 0, 2 to the 0 is 1. If you put in a 1, you get a 2. Put in a 2, you get a 4. If you were to put in a 3, you'd get an 8. So I'm going to graph that one by starting at 0, 0. You go -1 and up a half. 0, 1. 1, 2. 2 up 4. And 3 up 1, 2, 3, 4, 5, 6, 7. It'd be up here. This thing is going to run along the axis because that's the asymptote, and it's going to head toward that point right there. So now the circle, we said it was shaded inside. This is saying, oops, and of course I got to go back because I didn't look to see. But my blue line is actually a dash line. So dash line running all the way up through there. All right. It is saying less than that. Well, less than that should imply that we are below the curve. But pick a point. 0, 0. 0, 0 should work here. It should be in the shaded region. If you put in 0, sorry, I got the wrong thing. If you put in 0 right here for x, 2 to the 0 is 1. Well, what is going on with this one? It's saying that, actually, what did I just pick? I picked 0, 0. So this should be 0, sorry. And that means 0 is less than 1. That is true. So if it's true, that means we're in the shaded region. We know we're inside the circle. So for this one, we would be everything along there, all the way around here, and everything in between. This would give us what we're looking for. So hopefully everybody sees how that works. Test a point. If you're not sure, make sure that your point makes sense in terms of the actual problem. All right, looking at number 5. Now, number 5 is kind of weird. It's like there's 4 things going on here. This would be a line, and it's dashed. This would be a line. It is also dashed. This would be a line, and this would be a line. So we have Basically, we have that many lines that we have to deal with in terms of this problem. Now, x equal or is greater than 0. Well, that means this line right here, which normally I would make an x, I'm just going to use a dash line here and say this is x equals 0. And then my y line also is the same. I'm going to make this a dash line just so that we can see what's going on here. And this is y equals 0. So there are my two, and it's saying it's greater than 0 for x and greater than 0 for y. So we are in the first quadrant. Now I need to do some work on these other ones. I need to solve this other one. So I'm going to start here and say subtract your 25 to the other side. So this is going to be negative 25x and plus 1,000. And then I'm going to divide by 40. So y is going to be less than or equal to, this is going to be negative. Taking a 5 out, so this is going to be 5 over 8 x, and then 40 into 100, that's going to be 25. So plus 25. So there's that line. So I've got to go to my picture here and try to figure out where I'm going to go for this one. I'm going to label this. I'm going to change my labeling. I'm going to make this 5s. I'm going to go by 5s. And I'm going to do 5s because I'm crossing obviously at 25. So I'm going to need to do at least 5s to get to the 25. So with that in mind, I'm going to go up 5, 10, 15, 20, 25. Here's this y-intercept. And it has a slope of negative 5/8. So how do we do that one? Well, we're going by 5. So down 5, I got to go over 8. Kind of puts me somewhere in the middle of this one. And then down 5 and over 8 again would put me over here. And then down 5 and over 8 again would put me about there. And then down 5 and over 8 again would put me about there. And then down 5 over 8, I'd be just off the graph here. So this one is running something like this. These are all dashed lines, and I would be doing something like this. There's that dash line. Then I would need to do the next one. So the next one, it's saying x plus y is equal to 30. So y is going to be not equal, but less than. And remember, we're less than that line. So right now we're in this little triangle. That's where our shading would be. This is going to be negative x and plus 30. So I would go to 30, which is right here. And negative x means I'm going down by 1s. Well, that means then I'd go over to 30. This is 5, 10, 15, 20, 25, 30. Here would be my other point. And this thing would be just doing something like this. Remember, use something with a straight edge. It's going to be really important in the next section that you do. That means we are less than that one as well, which means our shaded region, all of our solutions, will fall if these two cross over, let's say somewhere maybe right about here. Then it means that all of our shaded region is just going to be, gosh darn it, come on. We'll call it right here. It's everything that is in this area. And it's defined by those lines. So your answers should fall in there somewhere. Hopefully that does make sense. Now, this next one. This next one, they're giving you the graphs, and they want you to come up with the equations for these graphs. So first we got to identify what they are. The first one is a rational, the blue one. It's going to be something in this form. Y is equal to, you're going to have an a value over x minus h plus k. And then the second one, the red one, is an exponential, and it's got to look something like this as an exponential. We're going to have some sort of growth factor b, and then it's going to be x minus h plus k. So here's what we have to this point. Now, I need to figure out what I'm going to do with these. And the way that you kind of want to look at this, the way I'm going to look at it anyway, is first I got to figure out what's going on with my rational. Well, if I look at this rational, to me it looks like it's got a asymptote line running right here, and it's approaching this one. So it's got an asymptote line running there, which tells me for this particular problem, my h in this problem is going to be the vertical line, which is +3. The k is the horizontal line, that's -2. So I have an h and a k, that's not a big deal. I'm going to plug those in. I need to find the a, and then how do I find x and y? In order to find a, I got to know x and y. Well, for x and y, pick a point. That's what you would do. I'm just going to pick this one right here. So I'm just going to pick that point. I'm over 1, 2, 3, 4. So 4, 0. Just easy enough to pick that one. That means then I'm going to do the following work here. I'm going to replace everything, try to solve for a, and then once I have a, then I know I can write the equation. So I'm going to say y, that's 0, is equal to a over, because I don't know a, I know x is 4, and I know my h is 3, and I know my k is -2. Well, then that means I'm going to add 2 to this side, and it's a over 1. Well, that means a is 2. So the equation for this one is going to be y is equal to my a value, which is 2, over x -3 -2. That is the equation of the first one. So write the system. Now I need to find the other one, the red one. This one's a little trickier because it's an exponential function. So the one thing that I would want to do here, I would want to figure out how this thing got shifted. And looking at it, normally the parent function, this being the parent function for one of these, and I'll just use, I'll just pick 2. I'll just say it like that. So I would normally, to graph this, and we did this earlier, we said if it was the parent function, if I put in -1, I should get a half. If I put in 0, I should get 1. Well, this is the important one right here, because that represents this one right here. I know there's an asymptote line running right here. That tells me for this one, my k is going to equal 4. I got to figure out what the h is, and I got to figure out what the growth factor is, and I got to figure out what a is. And that's where we're going to take this thing. Here's the rest of them. We said 1, 2, we said whatever. So we came over here, and then we graphed this thing, and we did the following. Let me find a color that I can use here. I'll pick orange. That'll be different. So orange for this one. So I'm going to plot those points like I was graphing the parent function. It's right here. It would say right here. Of course, it didn't change. Why did it not do that? Because I canceled it. So here's this one. Here's this one. The next one up would have been right here, and it would have looked something like this running through here, right? We just did that picture up there. Now, this point relates to that point. So how did that point get shifted in terms of right and left? Well, it got shifted 2 to the left. That means h in this problem is -2. Does everybody see that? Hopefully. Now, what else do we know? Well, we know a is, it's negative because it's upside down. It should be going up, and it's not. So I know there's going to be a -a. I just need to figure out what the b value is. Well, if I look at this point and I put it over here, and I say that that point, this one right here, should be right there. Let me find a different color. Hold on. Let's see. Color for this pen. Let's make it, I don't know. Purple. Okay. Purple. So I know that that point should be right here, which wouldn't be a big deal if this is 2. But then if I were to go over 2, this point right here should be, according to this thing, if we were to flip it over, it should be from the center over 1 and up. 1, 2, 3. It should be right here, because I'm kind of mirroring this. So this is 2 away. This one is 2 away. But if I put this point in, I'm only right here. And that doesn't work here. That's not going to work for this one. So it's not 2. I would try 3. If I put in 3, I'm going to get a 3 here. I'll just make a new one of these. Actually, I don't want to do that there. I'll make a new one of those. So I'm just going to say here is this new one. Here's x and y. If I put in -1, I get 1/3. If I put in 0, I'm going to get 3. Sorry, 1. If I put in 1, I'm going to get 3. Well, that makes sense. I'm over 1 and up 1, 2, 3. So my growth value is 3 in this problem. And now I just need to find my a value. I'm going to pick a point on this curve. So I'm going to go -1, 1. So my point that I'm going to test is -1, 1. Plugging that into this general form of this equation right here, it's going to say -1 is equal to, this is going to be a over, not a over, that's the other one. Sorry, a times, so a times the b value of 3, and then an x, well my x in this one, sorry, man, I'm really messing this up. My x in this one is going to be not, so my y is 1, not -1. My x is going to be -1. My h was -2. That makes +2 right here, and +4. That means when I do this particular calculation, I'm going to get the following. It's going to say 1 is equal to, this is going to be 3 to the first power, which is just 3, and +4. Then I'm going to subtract. I get -3 is equal to 3a, and a would equal -1. So what is the other equation that goes with this? This was the first one, and my system of equations then would say y is equal to -1. You could put that in if you want. 3, this is x plus 2, and minus or plus 4. Those would be the two equations that would create this system. Whoops, one last thing. One last thing on this thing that I forgot. Remember, these are not equal signs. So this wouldn't be an equal sign. This one has to be less than or equal to. And this one has to also, this one has to be greater than or equal to, because it has to be bigger than the red curve and lower than the blue curve. And you would end up in that region right there. I know that one's kind of crazy. It's just kind of a backward motion here and trying to get those. Last part just says, what real life situations could these be represent? Well, mostly it would represent business decisions. As we will see in the next section, that is going to be a really big part of this, is break-even points and maximizations and minimizations of problems. All right, hopefully that makes sense. I don't think you have one that difficult, but if you do, this is what you would do to come up with this answer. You just got to think about graphing something in reverse if you're asked for those questions. If you got questions on this, talk to your teacher. They hopefully will explain it for you. Have a good one. Bye.